Welcome back, aliens. My name is Navin Reddy, and in this course, we are going to learn about Git. Now, when you build an application, apart from learning the language and the tools to build the application, there are other things which you have to learn about, and one of it is Git. So that means irrespective of what kind of application you are building, it can be mobile, web, enterprise, you will be using this tool for two reasons. One, for the version control, and second, for the collaboration. And then this tool is actually easy. It's just that the concept might be new, and most of the thing which we do is through commands. And of course, you can do most of these things with the help of GUI because most of the IDEs provide you with this tool. But then when you work with the command line, you have more power to change stuff. So in this course, we are going to learn different things. First of all, we'll understand what is Git, how do we do the setup, how do you create your own repository, how do you create an account on GitHub, how to initialize the project, commit the project, and how do you push your code on the GitHub repository, how do you create branches. And we'll be doing that practically, so you will enjoy this course. And don't worry, the course is designed for the beginners. Even if you have no idea what Git is, we will take care of. So I hope you will enjoy this course, and also make sure, don't just watch the video, practice the thing by yourself. So whatever I'm doing, parallelly you can do it on your machine, and let me know how it feels, or if you have any issues in the comment section. Git is a distributed version control system. Now the problem is, if you want to understand Git, you have to first understand what do you mean by version control, right? And then we can discuss about version control system, then we can discuss about why it is called distributed, and then Git will make much more sense. So let's talk about version control. See, the thing is, when you make a project, of course, it can be any project. It can be a software project, or it can be writing a book or making videos. It's all about a project, right? And when you make a project, the way you work is you create different versions of it, right? Okay, so if you don't want to say version, let's say you make multiple updates. So when I start writing a book, I will write something and then I will edit the same file. Or maybe I want to go back to my previous file. So let's say if I'm writing chapter 1, I will complete that chapter 1 and then I will go for chapter 2, chapter 3. Now at every chapter end, I will just try to save it, right? And then on chapter 2, I will try to save a file. On chapter 3, I want to save a file. Or maybe while writing this chapter, in between, I will do the save, right? And saving is very important, right? Otherwise, if your laptop crashes, you will lose all the data. So as a writer, we normally say Control S not once, multiple times, just to be on the safe side. The important part here is we want to make the copies of it. Now there are multiple ways of doing that. What you can do is you can save the same file. The thing is, if you save the same file, you will lose the previous file, right? Or what you can do is you can create a new file. So every new update will be a new file. And as a software developer, we used to do that. In my college days, I remember when we used to create project, every time we add a new feature, we used to create a new folder. And let me know if you have done this, or maybe you can just give a smile if you have done this. We create a project and then we give a name to it. Let's say the project is for a quiz application. So you will say quiz app. And then if you think this is, now we have added few features, we can say quiz app 1, quiz app 2, quiz app 3. Of course, it will have a new updates, new features in that particular new folder, right? And then the moment you feel that project is complete, you say quiz app final. Then you say quiz app final, because maybe you want to make some final changes. And then you realize, oh, there's a bug. Then you say quiz app final, very final. Okay, so this is the type of folder we used to create. The thing is, why do we do this? It's because what if you want to go back to the previous version? What if you have created a project and then it's working and now you added new features? And then you thought it is working, but it's not. There are some bugs. You may want to go back to the previous version, right? Now having that version called, or having that power of going back to any version, that is called version control. And to achieve this, you need to use some software, right? Some system. And that system is called a version control system. So example, if you're building a project, you will be saving that file multiple times and then you will not replace the older project. The older project will be there, right? So let's say you have a software with X number of features. So you got the first 2 features in the first version, then you got the 3rd feature on the 2nd version. And at any given point, you can go back to the previous version. Also, what if you are not alone in the project? You have multiple people working in the same project. How do you collaborate? That's also important, right? So you will get those features with the help of version control. And as I mentioned before, you need a system, so we call it as a version control system. Now when you talk about version control system, we can categorize into three parts here. The first one is a local version control, which simply means that as a developer or as a creator, if I write softwares or if I write a book, if I write something and if I want to save in my own machine with different versions, of course, that is local copy, right? And in my own particular machine, I'm creating different versions of it, maybe having a folder inside a folder, then having different folders of it, or maybe I can just create a database where I will save all these files. Again, that's my choice, or that depends upon the version control system, but the thing is, everything is happening on my machine. The problem here is, what if I want to collaborate with other people? I have, let's say, 5 people in the team, and we all want to work on the same project. How will we do that? And also, what if I'm relying on my machine and then one day my machine says, okay, I'm done, I'm not going to start again. How will you get your projects? And that's where you can't simply rely on local copy. And that's where we have one more option, which is called CVCS. So VCS is version control system, CVCS is your centralized version control system. Now in this case, what you do is, let's say you have 5 people in the network or 5 people want to work on the same project. So what you will do is you will use a central repository, not the local one, but a remote one. So all these machines which you are working on in different locations in the world, you will be having a centralized version control system. Now at this point, every time you want to make a change, you have to get the copy from the centralized system, make the changes in your machine, and then you have to save it on the centralized version control system, which is CVCS. Now the problem with this is, okay, first of all, let's talk about the advantage. The advantage is, if you're working in a file of a group, everyone have access to it. So they will know what you're working on. So let's say you have done something, and then when you say save, now basically since we're talking about Git, let's use the word which we use in Git called commit. So let's say when you commit something to the centralized server, now at this point, the other people will have a recent code. They know what you're doing, right? But also there's a problem. The problem is everything is stored on a central system, right? What if the central server says, I'm done, I'm not going to start again. Your data is gone now, right? So that's the problem with this centralized version control system. Now that's where we have to look for an alternative, where you should be able to have a copy on your machine as well, and not just the current version. You should have the history as well. Because in the centralized version, even if your server goes down, at least you have a local copy of the current version. Yes, you have it, but we don't want just current version. What we want is the history, right? And that's where you can use something called a distributed version control system, where you will have a local copy, but not just the current version. You will have the entire commit history. So let's say you have created version 1, version 2, version 3, everything will be present in your local machine as well. And you can collaborate with the other developers or with your colleagues basically. So we have done with the first step of what is Git by understanding something called version control system. Now, the more theoretical concept you know, it will be easier for you to work on the Git software, right? So basically, Git is a distributed, which means you will have a local copy. Of course, you can have a remote copy as well. There are a lot of options available. Example, let's say if we talk about GitHub, GitLab, Bitbucket, all these are your remote repositories. So you will have a copy there, plus you will have a copy on your local machine as well. So let's say someday if you want to work in a long flight and you don't have internet access, you can still work on your project because you have everything in your own machine. So let's understand the history of Git. Now it is interesting, that's why we have this special video for it. The thing is, if we talk about any open source project, so what happens in open source project is, we have multiple people working on the same project, but you will say, hey, that also happens with the normal projects, right? The thing is, in normal projects, we have limited set of people. Let's say if you are working for a company and you are building a project, you have, let's say, a set of people in a team, they will be working on it. And then you trust everyone because they are a part of a project. In the open source project, anyone can contribute. Let's say one day I decided to be a part of one open source project. Of course, it will take some time for me to understand the project. And then if I feel, hey, everything is good in this particular project. So let's say it's any OS. Let's say we have this own Telusko OS, and then one day I want to contribute to that particular OS. I want to add a new feature of, let's say, a Bluetooth connectivity, just for an example. I can write my own module and add that in the OS in my machine. But if I want the entire world to use it, I have to send them the new code, right? But then how this thing will work, how multiple people in the world can contribute to one project. In the earlier days, we used to do something called archive files or sending the patches, right? Now, this is the same thing happened with Linux as well. Now, if you know Linux kernel, very famous one, the founder is Linus Torvald, and he is very particular about how Linux should work, what are the features we should have. Now, initial days when 1991 to 2002, it was more about if you want to provide the features, you can send patches or you can use archive files. But then in 2002, they started using some proprietary tool called BitKeeper. Now, BitKeeper I think was free at that point, and then they started using BitKeeper so that they can get the contribution from the world easily now. They don't have to go through a manual process of doing that. So they can simply use BitKeeper and they can send their code, and then they can do the merging as well. Now the problem is, at one point the policy of BitKeeper changed and they started charging. Now the Linux community was doing it for free, and then the entire world was using Linux for free. So they thought it's a good time now to move away from BitKeeper, and that's where Git was formed. Of course, they tried to make it very different from BitKeeper. So BitKeeper was working in a different way, and Git worked in a different way. Again, what is that different way? That we'll understand once we start the actual implementation. But that's how in 2005 Git started. It's not like someone thought, hey, let's do this version control system. No, they were using something else. It's just that because of some issue between the BitKeeper and the community, they moved away from it and they started using Git. As I mentioned before, Git is different from all different version control systems, right? Even different from BitKeeper. And since it is different, it has given some amazing features. It is very simple to use. It is fast. It also allows you something called branching. Again, once we move towards the advanced part of Git, we'll understand what branching means, and it's a fun concept to learn and also to implement. And it is fully distributed, which makes Git very famous. And I know we have done enough build up, and the question is, how do we use Git? We want to collaborate and we want to work with Git so that we can collaborate with different people and we can build a project. It doesn't matter, is it a proprietary project you're working in a company or open source? How do we use it? And that we'll understand in the upcoming videos. Now it's time to install Git. Of course, right, we want to work with those commands. And as I mentioned before, if you want to master Git or if you want to use the features of Git, command line or basically commands are the way to go. Now, how do you know that in your machine you have Git? Now, if you are using Mac, basically in Mac, if you have installed Xcode, you will get Git by default. But if you are using Windows, you will not get that. So how do we verify? So it's very easy. You just have to use the command prompt. So I will open my command prompt here and or PowerShell. So what you can do is you can search for Git version. So basically this is the command which you have to fire. And when you say enter, you can say it says the term Git is not recognized as a command. Okay. So if you want to get Git on your machine, if you're using this on command prompt, you will get a different message. Example, if you do that on command prompt and if you say Git version, this is the message you will see. So it doesn't matter which window you're using, PowerShell or command prompt, both works, but in both of the cases we don't have Git. Now how will you get Git? It's very simple. You can just go to the website or you can just go to Google and search for Git download. Now this is the website from where you can download the Git. The current version of Git is 2.41. So we can get that one. And it will ask you for which OS you're using. Now, since I'm using Windows here, we can click on Windows. If you're using Mac, you can go for that. And as I mentioned before, if you already have Xcode installed, most of the time, for some reasons, you install Xcode even if you don't develop iOS application. So do check if you already have Git by saying git -- version. If you don't have it, you can follow the similar steps. You can click on download there and you will get it for macOS. For Linux, you have to set the path and that should be simple. So let's go for Windows here. And once you click on that, it will ask you for which version. So basically, you can go for a standalone installer, which is suitable for if you have only one machine. But let's say if you want to move between different machines, you can go for portable one. But I prefer to go for a setup inside the machine and 64-bit because my machine is 64-bit. So I will click on that. So it's only 57 MB. So depend upon 58 MB. So depend upon when you're installing it, which version you have, you will get that. Now, once you got this download, it's very easy to do the setup. You will say click. So given a prompt, click on yes. Okay. And we don't have a choice, right? We have to accept the agreement. Now, this is a place where it will install Git. I will say next. Okay. It says I already have Git in my machine because I think I already installed it before. But I will say, okay, I'll go with that particular folder. That's fine with me. Now it also gives you something called git bash. Now at this point, we'll not be working with git bash. We'll be using normal CMD. And anything else looks good. Click on next. Okay, click on next. Okay, so it will give you certain options. When you want to edit something in Git, which particular uh, IDE which you want to use or node editor which you want to use. Now I will go for default one, which is Vim, or you can choose whatever you want. Maybe let's choose Notepad for this particular series. I don't want to confuse you with how to use Vim commands. So let's use Notepad here and click on next. Now this is something important to remember. Now when you work with the first command of Git, it creates something called branches. Okay, so we have this amazing feature of branch in Git. Now, by default, you will get one branch which you work with, and they call master branch. Now, when Git came into existence way back, the name was master, but recently, again, it doesn't look good, right? Master slave. So they went for a normal word which you can use. So we got main. So if you can see, we have an option of main here. So I will go for let git decide, and when we are creating the project, we'll make it main. We'll not be using master. Otherwise, you can change it from here as well. That perfectly works. I will say let get decide. Next, and here you can see I'm going to use command line, not git bash. So I will go with that and click on next. Okay, I will use OpenSSH and yeah, OpenSSL. So nothing to change much. I will let you know when you have to change the basic configuration. And fast forward and merge. Yeah. Okay, so when you say git pull, this is what you do select. I will say okay. And next, enable system caching required. Now it provides you some experimental features. We'll not be checking at this point. We'll click on install. Okay, so it will take some time to installation. Let's wait for it. Okay, as you can see, it is installed. I don't want to see release notes. I will click on finish and done. We got the Git setup. Now, how do we verify? Of course, when you open your command prompt or PowerShell, let's say here, if I try to do that once again, you can see it still says Git is not a recognized command. The thing is, after installing Git, you just need to restart your command prompt. And I will again open my PowerShell. Of course, you can search for PowerShell from here, and you can search for Git version, and you can see we got the Git version. So now Git is properly installed. Okay, now once we got the Git installation, now it's there, right? It's there in your machine. But how do you make it your own? Every time you do git commit, every time you want to push something, you need to have your own identity. Of course, we need to know, right, who is pushing the code. Because in Git, we have multiple people working together on the same project. So whenever someone pushes the code on the server, you should know who is doing it. And that's where you need to have your own configuration. The way you can check that is by saying git config. And when you say enter, okay, you can see it will give you certain things. Now, basically, in git config, there are certain things which are to mention, at least two things. One is your name, your username, and second is your email. With the same email, if you're using a public repository, let's say GitLab or GitHub, you'll be having a public account, right, with the email ID. So you have to use the same thing. So if you want to know what are the existing variables we have, so what you can do is you can say git config. I want the global values and I want the list of values. When you say enter, okay, so the thing is in my machine, I already have this configured. Okay, so this is not the first time I'm using Git. So I have these values, but in your machine, you'll not be having this value. So let's do the setup. How do we set the values here? Now, since I'm using my personal email, so that's why it is blurred because of the privacy issue. But yeah, so you can use your own email ID there. So how do you set a value? It's very simple. You can say git config. So let me just clear this screen once. So if you want to configure, you have to say git config, and then you have to say global because you want to set it globally. And then you need to mention user.name and whatever value you have. So let's say I want to set Naveen here. Enter. So that is what is setting my name there. Next, I want to set my email ID. As I mentioned, you need to set it at least two. Remaining we'll see later. User.email, and I want to set my email ID. And again, for privacy issue, it is blurred. I will say enter and values has been set. Now, if you can check the same command, you will get your details there. So that's how basically you can make this Git your own. Now, how do you create your first project? As I mentioned before, this is not just for coding. You can use Git for any purpose. The moment you want to create something with people, or maybe if you want to create something, maybe you want to write a book, maybe you want to write poetries or essays, you can use Git there, and you can maintain the versions of your stories. So once we have done with this setup, so now we have Git on a machine, right? Let's try to use Git. Now the thing is, normally as a programmer, we use Git for different languages. Example, let's say if I'm making a project in Java, I can use Git to create different versions of it, and I will be committing it. I will also push that on some public repository. And then in the world, we don't have just one programming language, right? We have so many programming languages. Now, if I go with any specific language here, of course, it will create trouble for others. People, let's say if someone is doing into JavaScript or Python, they will not feel comfortable with Java, right? And the beauty is, doesn't matter if you're writing a programming language or a essay, some lines of statement, English statements, it's all same for Git. It's not like Git recognize the programming language and say, hey, for this programming language, I will work in this way. No, that's not how Git works. Git basically says, you give me the file, you give me the statements, I will take care of it. So Git will not look for the code, right? So in this particular course, we're not going to focus on any programming language. Let's say we are writing a code in multiple files. Doesn't matter the language. So it's important for us to understand how do you store that file with Git? How do you work with Git to merge different files? So whatever lines I write, it will be normal English, maybe a pseudocode for that matter, but this can be used by anyone, even if you're writing a book or if you're writing a script for a video. Okay, so let's get started. So what I will do is, first of all, if you want to type something, you need a editor, right? Now in this particular course, I'm going to use VS Code because that's very famous. So in my machine, I already have VS Code installed. So let me open that. So I got my VS Code open here, and I will just reduce the size of a bit. Yeah, okay. So this is my VS Code. You can use any IDE for that matter. And then in this, I will just open a folder. So this is where I will be working. I will be working in general. So let me open a folder. And let me create this folder inside my user, which is Naveen in this case. And I will create this folder as first project. Of course, this can be anything, but let's say first project and opening it. Now imagine this as your working directory. So what is working directory? Example, doesn't matter if you're writing a book or writing a code, you will put that in a folder. This is what your folder is. So you can say this is your working directory, right? And now I will open a terminal. Now, as I mentioned before, we need to do everything on a terminal, right? So if you're using VS Code, you get a terminal inbuilt. Or if you're using some other IDE or some other editors, let's say Notepad, in that case, you will be using your command prompt, right? Now, whatever we did before, we did that on a command prompt. Here, we are using an internal command prompt of VS Code. We call them as terminal here. Again, same thing, different terminology. In fact, you can also select, do you want to work with PowerShell or do you want to work with any other thing? So in this case, when I say terminal, it is by default using PowerShell. So that's fine. We have tested this on PowerShell. It was working. So let's continue with it. Basically, if you want to understand Git, you have to understand different areas in which Git works. Now, basically for Git or not for Git in general, this is your project, right? So you can imagine this first project as your folder. Now, whatever you do inside this, Git has no idea what you're doing. Okay, you have to let Git know that, hey, I want to track my progress. I want to commit. I want to create different versions, right? And to tell that to Git, you have to do something. Now, basically, apart from your working directory, we have something called a staging area. Now, staging area is a place where Git knows, okay, in your project, you have, let's say, 10 files. Out of 10 files, you have 5 files which you want Git to track. Now, how will you tell that? And that's where staging area comes into picture. You have to tell Git, hey, whatever is there in the staging area, please take care of it. Other files, you can ignore that. Okay, so staging area becomes important because that's where Git works. Apart from that, we have something called a commit history. As I mentioned before, you can create different versions, right? And every time you commit, you create one version basically. And the beauty is you can go back. Of course, I will show you those things, but these areas are important. So you are working with this directory, and whatever you do in this directory, Git has no idea, okay? And if you say, hey, Git, do something with this, Git will say, what are you saying, bro? So basically, Git has no idea what you're doing. So you have to push that into a staging area. How will I do that? We'll see that later. And then one more area we have is the commit history. Now, how exactly all this thing looks like, we'll see that later. But you have commit history where you have to do committing. Now, this too, which is your staging area and your commit history, they become a part of a different box, which is your Git. A lot of people do get confused between a working directory and a Git repository. There are two different things. It's just that it looks similar. So they say, okay, this is my Git repository. No, this is different from the Git repository. This is your working directory. Okay. So now what I will do is, whatever files I have, I will create here. they have no, so Git has no idea about it, right? So I need to create a local repository here. So when I say local, it means it's there in this machine. What if I want to share this with everyone else in the world, or maybe with my team? In that case, I will create a remote repository. This can be done with the help of GitLab or Bitbucket or GitHub, your choice, but those are the options we have. Now here, we need to create a Git repository or local repository. The way you can do that is very, very simple. You just have to use a command git as we are using. First of all, before we're going forward, I will say git version, and you can say there's a version, right? Now, if you want to create your Git repository, local repository, you have to use something called init. Okay, so once you do that, it will create a local repository in your project. Okay, so before going this, what I will do is I will use one more command. Now this command is very important, which is called git status, and we'll be using this multiple times. So every time you want to do something, you will use git status a lot. So when I say git status, it says there's not a git repository. Okay, so we don't have a repository. Git says, hey, you are trying to run status, but where is a repository? As I mentioned before, the folder here, which is first project, is your working directory. If you want to use git, you need to initialize git. So you have to say git init, and this will create the empty git repository. And now you have git here. So where do we find it? So you can see we have this path, which is c/users/naveen/first project /.git. Now this is your folder. Of course, this is a hidden folder, but this is where it tracks everything. So the staging area, the commit history, everything will be present inside that Git folder. And this is different from your working directory. Example, whatever file you create here will be a part of your project, but not part of .git. That's important to remember. In fact, till the end of the project or end of the series, this is something you have to remember. By default, when you create a file, it will be part of your working directory. You have to let Git know that this should be a part of Git, and that goes into staging area. Okay, so now again, let's do Git status, and you can see now Git status works. But then it says Git status is on branch master. Oh, now this is something we forgot to do. Remember when we were installing Git, I've mentioned that by default, when you initialize your Git project, you will get a master branch. But what we want is a main. We don't want to use master. We want to use something else. It can be main. It can be a demo. It can be any other name for that matter. Here we have the master. We don't want master. But even if you have master here, it says there's no commits yet. Okay, so we have not created something. We have not done the committing yet as well. Again, what is commit we'll do, we'll see that later. But at this point, we don't want this name, right? We don't want master. So what you can do is you need to remove git. Now, do we have a way to remove git here? No, we have to delete this folder. So you have to delete .git. Okay, so we can say rm-rf and we can say delete git. Okay, it says why. Okay, don't have sufficient rights. Okay, that's fine. I will just delete that from outside. Okay, so how do I delete that? So what we can do is here we cannot say hidden folders, right? So let me jump to that folder. Okay, this is a folder, right? Now here we have .git. We can simply shift delete and gone. Now if you try git status, you can say it will say not a git repository. And now let's initialize it. Now the way you can do that, if you say git init, it will by default give you a master. We want main, right? In that case, you will use something called -b and main. So basically now you're saying that. So again, we'll talk about that B later when we talk about branches. But here we are trying to say that whenever you initialize this project, make sure that you have the main name, not the master. When I say enter, okay, it says empty project created or empty git repository created. And now if you say git status, you can see the branch name. Okay, so it's revealed, right? So the -b is branch here. So branch is main, not master in this case. And we are going to continue with main till the end of the course. Now, once we have done with the initializing of the project or initializing of the Git, how do you add files? That we'll see in the next video. So basically, we were able to create a project here. Of course, we got an empty folder, which is your working directory. And we also able to get the Git in it. Remember, we got a main branch. We have initialized the Git project. Now, basically, the way you can check if everything is working fine, you can say Git status, and we are doing this from last one video, right? So Git status will give you the status of your Git project. It says on branch main. That means we are on the main branch now. Of course, in future, we'll see how do we create different branches. And it says there is no commits yet. So of course, we have not done the commit yet. And then the project itself is empty. Now what I will do is I will create a very simple file. Now the thing is, it doesn't matter what type of project you're working on, a software project or a book project, you do create different files, right? Now I don't want to go for any language specific things here related to programming. Let me create a general file. And let me name this as my first code.txt or txt. So instead of going for .java, .c, .cs, which is C#, .cpp, let's go for .txt. Now this can be a coding file as well. Git for Git, everything is same. It will treat txt as any other file. Okay, so what I will do here is, I will write a very simple statement and I will say, hello world. Okay, so that's it. Nothing much, a very simple line in my first line of code. Now the thing is, this project or this file is there in your working project, right? If you remember, we have talked about those different areas, right? We have a working area. So working directory, this is where you edit your files and as a programmer you work with. But if you want Git to handle this, you need to add that in a staging area. If you don't do that, what happens? Let's try. Now here what I will do is I will say again git status. It says there is an untracked file. Now the thing is, if you want to commit something, if you want Git to take care of some files for different versions, you have to give that to Git. And the way you can do that is by adding that particular file to this staging area. Now at this point, we have not done that. And that's why it says, so let's read everything. So it says on branch main, that perfectly makes sense. No commits yet. Of course, we have not done the commit yet. But it says there is an untracked file. Okay, there might be multiple files, but here we only have one, which is first code.txt. Okay, it says nothing to add to commit, but untracked files present. Okay, you know what happens? Let's say we have this file and now I want Git to handle it. Now the way you can add it to the Git by using something called a commit, right? So we use git commit. Imagine git commit as saving something, but then Git will not directly save this. You have to make sure that you add this in staging, and that's what it says here. Now, if you want to add a particular file to the staging area, this is the command you have to use. So what is the command? It is git add. So that's the two words you have to use, git add, and then you have to mention the file name. The file name here is my first code.txt. Okay, and when I say enter, now this is added in the staging area. And now once you have done that, let me just clear the file or clear this screen. Once you have added the file to the staging area, when you say enter now, you can see it says something. It says on branch main, makes sense. No commits yet, of course. But then it says changes to the committed. It says there is a new file added called first code. Now, is it available or is it committed? Not yet. This is not committed yet. It is just that this is into a staging environment. Yeah, if you want to unstage it, you can use something like this. You can say git rm cached file to unstage, but we don't want to unstage it. We want to commit it. Now, how do we know that we have different commits? As I mentioned before, it also maintains the history, right? So whatever work you have done, so let's say in your project you have till now you have done 50 commits. And if you want to know all those commits, you can use a very simple command called git log. So with the help of git log, you can see all the initial commits, and you can see it says your current branch main, because that's my main branch, does not have any commits yet. So that means the file is there in your working directory. The file is also there in the staging, but not in the commit history. Now to achieve that, to commit this, we have to pass another command. And that command is very simple, which is the commit. Okay, so the thing is, one of the questions you might be having, okay, so once we say commit, it means it goes into the local commit, right? But how many times we should do that? And after how many files edit? So normally, let's say if I can think about my project and if I'm working on one feature, I will be thinking, okay, once I complete this feature, I will say commit, right? So that's why the project will be stored. That's not the case actually. It depends upon a lot of different factors. You don't work alone, right? You work in a team. So sometimes your company defines how should you commit, how often you should commit. Your company defines what type of messages you should have. That's right. So for this commit, you have to also pass the message. So for this particular series, we are not going to see when to commit. It's just that we have to understand how do we commit. Again, when to commit is something you need to decide based on your project. But then there's a common saying, commit early and commit often, right? So we are doing committing here. Now, if you simply say git commit, you can see it will not, okay, it is giving you some message here. Please enter the commit message for your changes and blah, blah, blah. Okay, so what I will do is I will just go back because this is the vim. Okay, so aborting a commit due to empty commit message. Basically, commit has not done. The thing is, when you want to commit, you have to make sure that you also pass a message. Of course, right? Every time you commit something, you have to specify what changes you have done there. So I can say, if you want to add message, you can say -m, and then you can pass a message, my first commit. Now, of course, this type of messages should be logical. It can also defines what features you have added. Maybe you have resolved some bug, you can mention that there. Or I have seen few projects or few companies, they also follow something called issue tracking. So let's say if there's an issue created or some tickets created, you also mention the ticket number, which ticket you have resolved, okay, something like that. And when you say enter now, it says one filed change, one insertion. That's right. So basically we were able to do our first commit here. So this is your first commit. It says create a mode. This is the file name. And now this is getting tracked by Git. Okay, cool. After doing this, I will say Git status, and now it says on main branch, nothing to commit, working tree clean. Okay, that's good. Now, if you observe, there is one thing here which I intentionally missed, which is this part. What is this number? That looks weird, right? See, the thing is, Git also provides you something called integrity. It means once you save something in a Git commit, you cannot change it without Git knowing about it. So basically, every time you want to make a change, Git will know that something has been changed. How? It basically follows something called a checksum. Now, checksum is something, imagine checksum as a fingerprint for the data. So example, if every time I change something in the data, it will change the checksum as well. Okay, even if a small change in your code will change the checksum, and Git creates a checksum for every commit. So if you try to change something here in the commit itself, because of course a local file, right? If you make any changes, Git will come to know that, hey, it's not matching. You have made the changes, but I don't have any idea about it. So I have the older version. So basically checksum is very important. Now this is done with the help of SHA-1 and it creates not this number of characters, it creates 40 characters. Okay, out of which we only focus on the first 7. So if you can see, these are the first 7 hexadecimal numbers. So we got FD914D5. Of course, when you do it on your machine, you will get a different number, right? Because this is unique to this particular data. But behind the scene, this is not 7, this is 40 characters. To display, it is only showing the 7 characters here. Okay, now since we have done our first commit, let's try git log. So git log will give you the log of all the commits. When I say enter now, you can see it gives you, it shows something. It says, okay, what I will do is I will just clear this screen so that we'll only see this particular message. Okay, so let's see what it says. It says there's a commit. Okay, makes sense. And who is the author for this commit? This person, Naveen. And that's my email ID, which is hidden, which is blurred. And this is the date. So this is when I have done this commit. And now when you see different commits here, there's also something called header. Now this will make much more sense once we start working with branches. But at this point, we have head to main. And the message is my first commit. The more commits you do, you will see all those things coming up there. And every one have a different commit. And this is the 40 characters thing I was talking about. So that's 5, 10, 15. Oh, this must be 40. Okay. So we only see first 7, right? If you can see up here. So when we created this, this was the first 7 characters, right? It's matching with this, the first 7 characters, right? But then this is in general, or behind the scene is 40 characters. Now that's how basically you do your first commit. So we are done with the first commit, right? And when we say git log, we got this particular commit here and we are happy with it, right? We got our first commit basically. So what I will do is I will make some changes. Let's say I want to add some exclamation marks here. Okay, so when I do that, and if I want to, let's say I want to do the get status, and as I mentioned before, this get status will be using a lot. So when I say get status, it says, oh, get status on branch, everything is clean. Maybe the file is not saved. Okay, that's the issue. So you have to make sure that you save the file because even Git is not sure what you have done. So every time you make some changes, save it in your working directory first. And now if you see, it says changes not staged for commit. Basically, there's a file which we have created. And now this is into a modified stage. Now that's right. The thing is, every time you make a change, or let's say every time you create a file, it is into working directory, right? And then you try to stage it. So that goes into the staging area. So we got a working directory, then we move that to a staging area. And then from the staging area, we do commit so that it will go to the local commits, right? So those are the steps which we take. So before making these changes, we had data in the local commit, and then it was there in the staging as well. The moment you make some changes now, it goes into, again, a working directory. Now, this is not staged. Example, how do I know this is not staged? Example, let's say if I do a commit now. So let's say if I'm doing a commit, and this time I will say this is my second commit. Of course, this is not a good way of writing message, but just for learning purpose, we are doing it. So when I say enter now, you can see it says changes not staged for commit. Basically, if you want to commit something, the data, the file should be there in the staging area. This is not. So that's important. So every time you make a change, add that to staging area, then move that to the commit. Now, how do we add it? We have done that before, right? We can simply say git add. In fact, let me just clear this screen. So I will say git add, and then I will say first code.txt. And then when I say enter, okay, so now this is into a staging area. And now once we move that to staging area, I can say enter, and now we have done with the second commit. So in total, we got 2 commits. Okay. If I do a git log to check how many commits I have, so you can see we have 2 commits here. This was your first commit. This is your second commit. And of course, with every commit, you get the message there. You get the time, which is mentioned here. And then you also get the author who has done that. So maybe if you are working in a team, you're doing some collaboration, so you will also know who has done what commit, and that's important. Okay, so now this is where my head is. Now the thing is, imagine head is a pointer. So even if you have multiple pointers in your local commits, as I mentioned, local commits, I have multiple, it's basically multiple commits, right? So you'll be having a pointer, which one is the latest one, or which one we are pointing to. So here we are pointing to this one. And again, we'll focus this more once we move towards the concept of branching. Okay, now what do you think if I add one more exclamation? So what's the step? First, save it. The moment you save it, of course, it becomes a modified version. So it is not staged. And you can see we also get a message here, or not a message, but in VS Code, especially if you're using some IDEs which supports Git in a good way, and VS Code does that. And you can see it says M, which is your modified. And the moment you add that to your staging, this will be gone. But what if, of course, staging is important, right? So from working, you move that to staging. From staging, you move that to commits. But what if you want to directly commit? Something like this. Let's say I want to do the commit, and I will say, this is my third commit. I'm very bad with comments, but this should be something like added exclamation mark or solved a particular story, if you're working in agile methodology. But here, let's say I have this particular commit, and now I want to do the commit without staging. Can we skip staging? And we can. If you want to skip the staging part, you can simply use a -a as an option. So say git commit -a, then -m for the message, and then you can pass the message. Basically, you are skipping the staging thing. So if I say enter now, you can see the commit has been done without going into staging area. Okay, so that's important. If you don't write -a without staging, it will say it is not tracked. So if you want to move from the working directly to commit, this is how you do it. Okay, now if I do git log once again to check everything is good, so you can see we got 3 commits. This is the third one, recent one. And if I say enter, you will also see the previous commits. So this is how basically you use -a to move the file from working directory to the commits. So let's try to understand the diff command. So basically in Git, we have this option of finding the differences between what you have worked and what is already there in the commits. So let's say if I make some changes here. So what I will do is I will first of all check the status of this, and you can see there's nothing in my staging or nothing to track, and I will make some changes now. So if I say hello world, so that's the greeting, and then I will say take input from user and add the values. So let's say I'm writing a pseudo algorithm here, and when I say save, and if you can observe, especially in VS Code, you can see this green line. This basically means you have added something, okay, in the file. And now if I go back here, and of course I can simply do a git status. Of course, git status will give me the changes here. But what are the changes? I mean, of course, git status will show you that this particular file has been modified. But what exactly is modified? I want to know that. So what I can do is I can say git and I can type something called diff. Now when you say git diff and when you say, when you say enter, it will show you the changes which happened in the file. And these are the changes you can see. It says there have been few changes, the number of lines. Now these are the number of lines which I have added. So we got hello world. In fact, there's a change here as well. Of course, we have not changed here. The only thing is I said enter, right? That's a new character now. Now, basically, this is the older one and these are the new changes. Now, if you want to see, okay, I'm doing a commit, it says it is untracked. I want to know what changes I have made. So you can use something called a git diff. So basically, it will check the commit, it will check what data you have in your working directory, and then it will track the changes. And now, once you have done that, maybe I want to add this. So I will say git add first code.txt and it's enter. And now once you have added, let's say git diff, now you can see there's no difference. The reason is now this is not into a modified, this is into a staging, right? Now once you move this to staging, I can also commit. But now what if I want to find the difference? I have added that to staging area and now I want to find the difference. In this case, again, you can do git diff, but since we are into staging, I can say -- staged, and now you can track it. So if you have your file in the working directory, and if you want to check the difference, you can use git diff, which is differences. And if your file is into staging area, then you have to use -- staged to check the changes because it's already into staging area. Once we know the difference, we can simply do the commit now. And of course, for commit, we have to pass the same thing. We have to say git commit. And let's say I'm basically working on a project where you have each task given a number, a story number. So I can also say story 3.1 and I can say message is user input. So basically that's how you can mention some messages which should be logical. Yeah, and now if you see git log, you can see the entire history. So this is the recent one which you have done. And then this is your third commit. And if you go down, you will find more. Let's try to understand how do we remove a file from a Git repository. So let's say you already created a file and then you have pushed that to a Git repository and now you realize, oh, that's not the file I wanted to put that into Git repository. Now, why you will not put something in a Git repository? Now think about this. You're working on a project and you have multiple files and one of the file is basically where you put your credentials. Let's say I create a file here. So this is where I will put all my password just for my references. So I will say all my creds.txt and this is where I will basically put my username password. So I will say username is nvn02 and my password is rdy03. So this is my basically username and that's my password. And I just want to save it for my reference so that I can just connect with the database or something. And I want this to be only in my particular machine. I don't want to push to the server, right? And after this, let's say we also have some README files. So we got readme.txt or readme.md. Basically, we have a concept of markdown. You know, if you want to make some document beautiful, we can use markdown to make it more beautiful. That's what Git uses. So basically we get readme.md and this is an important file in every project. So we'll also see that. And okay, so you can see we got U here, which is untracked basically. So let's say in readme, I will say this is my first project. Author is Naveen Reddy. Company is Telusko. Okay, so let's say we have these values here. Credentials we have already mentioned. And let's also do some changes in the first code. In the first code now, you want to submit data to the database. So let's say we have all these changes in the code. Okay, imagine this is a coding file of any language which you love, and we have made the changes here. And now what I will do is I will just see the Git status. When I say Git status, you can see it is showing that you have one modified file, and that's correct. We have done the modification, and you got two files which are basically untracked, and that's why it says. You can see if you see here we have U, which is untracked. Okay, now I know what to do. In fact, if you do status once again, you can see there's an option here as well. No changes added to the commit, use git add or git commit -a. So -a is basically an option of adding directly in one line itself. But let's say if I want to add all the files in the staging, how will I do that? Of course, if you want to add all the files, you can simply say git add and mention each file. So this is first code.txt, then you say enter, again do it for the next one. Or what you can do is, there is a shortcut, you can simply say dot. Now dot simply means you can add all the files in the staging area. Enter and done. Now all the files are being tracked. So you can say now it says A, which is added. And if I say git status now, so you can see we got a new file, 2 new files, and one is modified one. And if you want to make the changes, you can simply say git commit -m, and you can pass the message. You can say readme and story 3.2. Okay, so let's say I'm adding this 3. And then you can see we got the files in the database now, basically your Git database. Now, if I say git status, what happens? If I say git status, it says everything is clean, nothing to commit, and now everything is being tracked in the Git repository. That's cool, right? But then the thing is, I will now, after working for let's say a few hours, I will decide to push this to the GitHub repository or some public repository. Now at that point, what happens is everyone can see my username password. I don't want it. Basically, I don't want this file to be there in my Git. One way you can do that, you can just right click here and you can say delete, move to trash, and done, your job is done. But the problem is, if you say git status, it's already there. It says it is deleted, but it is deleted from your working directory, not from your Git, right? So one thing you can do is you can say, but if you do git commit, that's tricky now, right? So what was the idea here is, don't delete it from here. So git status, everything is clean. Don't delete from your working directory. You have to delete first from the Git. And the way you can do that is by saying git rm, that's the command you have to use. And then you have to mention that it is basically cached. So we have to say cached and then mention the file name, which is creds.txt. Now, when you say enter, it says removed, and you can see now it is untracked. So basically, first you have to delete your file from the Git. Now it is untracked, and you can happily delete now. Delete, moved, and now you can say get status, everything is cool. You can say changes to be committed. So I will simply say git commit -m, remove the creds file, and done. So now you can see we don't have anything here and we don't have anything in the Git. And that's how basically you can safeguard yourself from your unexpected file uploads. Now, if you remember, when we talked about Git, we have mentioned there are different types of repositories, right? Now, basically when you can have Git tool, which is a distributed version control system, you have a commit history in your machine, right? And then of course you can jump between the commits. But what if you want to collaborate with everyone? So let's say you are working in a team and then they are working on some feature, you are working in some feature. How will you collaborate? And that's where we have to use something called a remote repository. Now, what is a remote repository? So example, let's say we have 6 people in the team, they have their own machine, they have a local copy or local repository. And now if you want to share, we need to use some remote repository, some server, which will be public so that they can fetch and they can do something. Of course, this can be a private to the company, or this can be public so that you can access it from anywhere. But let's say at this point, let's talk about public because we are not working for any organization where the security is most important. We are learning Git, right? So let's talk about the public here. Now, there are different options we have. In fact, the options which you're talking about, they also provide you something called private. Again, we'll see those options there. Okay, so we have 3 options here. There might be multiple repositories, or multiple remote repository options, but here, the most famous is GitHub. Then we have GitLab, the second one, and then third one is Bitbucket. Now, Bitbucket is given by Atlassian, which is a very famous company. They provide different tools for the developers. So you can use this, and few companies are using it. Most of the companies who want to use the private features, the paid private feature, they can use GitLab, or they are using GitLab basically. And then for the public, for the normal people, or for the public, we have something called GitHub. Now, GitHub also helps you to create your own profile. And that's why if you go for the interviews or if you talk to people, they will say, hey, give me a GitHub profile. It's not like you can't work on GitLab or Bitbucket. It's just that GitHub is very famous among a normal public. So we are going to use GitHub here. Of course, you can switch to any repository your choice, but let's talk about GitHub. Now, first of all, you need to have your account on GitHub. Okay, so how do I get that? It's very simple. Click on sign up, enter details here, whatever email you have, and you can log in. Once you are signed up, you have to also make sure that you're logged in. And let me just do the login fast. And I'm just hiding my email ID there so that we can keep it privacy. And here we go. So I'm trying to log in, and that's my GitHub repository. Okay, so I have a lot of repositories here because when I teach something, I also push that code on GitHub so that you can see. And you can see all the repositories here. There might be some private repositories which you cannot see, but that's how it is. Okay, so we have some repositories here. Now, what if you want to create one? Now, first of all, how we can use GitHub, it's very easy. Let's say if you want to search a particular project. So what you can do is, you can search for something. Example, let's say I want to search for Linux kernel, which is a very famous repository. So you can see this is Linux, the Linux kernel which we use. It is open source and the entire source code is available here. Now, the owner of this is Linus, which is Linus Torvald. Everyone knows it, right? So you can see this is the entire code of Linux, and you can get this on your machine. Okay, it's very easily. Now, it also analyzes the entire code base. It will tell you which languages it has used. So you can see 98.4% of this code is C, some shell script, some Python script, and makefile. So these are the languages they have used. Contributors, you can see more than 14,000 contributors we have for Linux. And you can see these are some options. So at this point, when I'm recording this video, there are 8,000, more than 8,000 people are on this page. Okay, so that's interesting. Everyone want to look at the code, and they might want to modify it, or they might to add some new features. So basically for the project, you can also give stars. Example, if you like this project, you can give a star here. Or when you create a project, people can give you star, and that's how you become a good GitHub star. Otherwise, or you can pay some amount. Okay, I'm just kidding. So let's say we also have an option of forks here. Now, example, we'll talk about what is fork later. And this is 48,000 forks already happened here. Now, this is the entire source code. I can get this code on my machine. It's very simple. You can click on this code and you can click on download zip. Okay, and you will get the entire source code. But we are not going to do that options. We have two options here, which is HTTPS and SSH. We are going to do this. But how will you use this? It's very simple. Now, when you have this project, what you can do is, or for this, even to browse this, you don't need a GitHub account. If I'm not wrong, you can get this. You can simply copy this. Okay, so you can copy the link. Okay, first of all, we have mentioned the option, right? Download zip, that's one option. Second is you can copy the link and you can go to your terminal, and here you can pass a command which is git clone. Now, clone is basically copying something, right? So you have a code in the repository and now you want to copy it. So you can say git clone and you can mention the address. And the moment you say enter, it will copy the entire Linux source code on my machine. So you can see it is downloading. It will take a lot of time because I think it's heavy. I've never tried it, or maybe I've tried it before, but never completed the entire download. You can see even with this speed, only 2% completed, and that's the entire size. So I don't want to do this. I will just cancel this. Okay, I don't want to download the entire stuff. I just wanted to show you how do you get it. Okay, so that's how you can copy. There are different options here. We have HTTPS and then we have SSH. Okay, so we'll see later how do we use this, but at this point you can see we have some repositories. But what if you want to create your own repository? It's very simple. If you can see, let me just increase the font a bit. Yeah, so if you can see, there is an option of plus button. So I want to create my own repository. We have done that for the local machine, right? So when you say git init, it creates a local repository in your machine. Now I want to create a remote repository. For that, you just have to click here and click on new repository. Click on that. Okay, it is creating. Yeah. Now this is the page you will get. Now that's my ID, GitHub ID, and this is my repository name. So let's give a name to it. Of course, the repository should have a good name, and we have done that for our own machine as well, right? Example, when we were doing VS Code, remember we created a project and that was your repository name as well. Here, let me create something. So I will say git course because that's what we are doing and it is available. So again, this is not publicly checked. It will just check do we have in my account. So I don't have this name in my account, so I can use it. You can give a particular description here. So you can say Git course demo. And then you can make your repository public or private. Now Linux, we were able to search it because it was a public repository. Now let's say if you're working on a project and you don't want to share the code with the entire world, of course at that place you will be using a private one. So of course you can share the link with your friends, or not for the friends, but with your colleagues, and then you can work on it. Public, anyone can search on GitHub. So for this, I will keep it public so that you can also see the repository later when you're watching this video. And then there's an option of add a README file. So at this point, I will not do that. Now, README file is important is because let's say if you have built a project and if you want to mention some steps, what is this project? How do you run this project? How do you contribute? So all these things you can mention in the README file. But at this point, I don't want to add it. There's also an option of git ignore, which we'll see later. And then you can choose a license. There are different licensing options here. If you want to keep it open source and if you want anyone to use your things, at this point, I will not choose any license and click on create repository. And done. So you can see you got your repository here. Now, when I'm recording this video, there's an option of Copilot for AI programming, and I will not be using that. Also, I can invite collaborators. At this point, I don't want to do that. Just scroll down and you will see all these steps. Now, first of all, certain things which is very important. You can see a link here. Now, this link will change based on where you are clicking. So if you're clicking in HTTPS, this is what you will get. And most of the time when you're downloading URL or some repository, you will use HTTPS, but we will use SSH. So the advantages, okay, let's talk about those advantages later in some time. So let's say we got this link here. Just try to remember, we do get a unique link for your repository. This is unique. Now, how do we work with this repository? Now, one thing to remember, we have a GitHub repository, which is on the internet somewhere. I don't know where it is. And then I have a local repository. What if I want to make some changes? How do I do that? How do I push the code from my machine to the local repository or to the remote repository? Now to do that, what I will do is I will open my terminal. So my terminal was already opened. It's clean. First of all, let me create a folder here and let me name this folder as Git course. Okay, same name, but with my remote repository. And then I will jump into this particular folder, the Git course, and I will check, do we have any folder here? You can see I don't have any files or folders. Okay, first of all, I'm into Mac. So ls, there's no folder. That's cool. Now, what I want to do is I want to create some files. Now, first of all, we don't have any file. Let me create one file. Now, it can be any file, okay? And you can simply follow these steps here to do that. I want to push one file from my local repository to the remote repository. And you can simply copy paste and run. It will work. But let's try it one by one just to understand how it works. So the first thing that we do is we will be creating a file, which is README file. Remember, we have talked about README. So to do that, I will say echo and I will push some data here. So I can say git course demo and I can type multiple lines of data here, but let's say we have single line. And then I want to create a file called readme. Basically, this is a command. Echo is a command using which you can echo this message to this particular file. So we'll say readme.md. Now MD basically stands for markdown. If you want to design some readme file and it should look good, so you can use something called markdown. Okay. And you can see if I say ls now, we got a file created. And if you want to see the content of that file, you can say readme.md and you can see this is the content. So using cat command, I can just see the content. So I do have a content now. So ls, we got a file. The next thing we have to do is we need to create a Git repository, the local copy, okay? The local Git, which is not done yet because we got a folder, but it's not Git enabled. So to do that, I will say git init and we can follow the steps, or otherwise we can also create a branch name because by default it will create master, right? We don't want master, we want main, but let's follow the same steps. So you can see it has created a empty repository and that's done. So let me clear this. We got a repository as well. If I say ls, you can see we got, we should have got the folder. I think it's hidden. So yeah, so you can see we got a folder here, which is .git. Now this is where it will have all the folders which we have talked about before. So this is done. The next step is we need to add, because if you say git status now, we got a file, but that is not a path. So it is untracked. Remember? We have a working copy, then we have to stage it. Now, how do we stage it? We have done that before. So I will say git add readme.md. So now we have staged it. Now after staging, if you say git status, you can see we got a new file and this will be committed now. Now how do we commit? It's very simple. You will say git, okay, I'm just trying to copy the code from here. Okay, so on the left hand side, you can see we have the code or the commands. We'll say git commit. We'll mention -m for the message. And here I will say first commit, enter. So that's my first commit, right? But again, this commit is happening in my local machine. So that's done. Next, we have to create a branch. So I will say git branch. Okay, now why do we have to create a branch here? The thing is, by default, we got a master branch, right? And we have mentioned before, let's not use master. Let's use something called main. And that's what GitHub is also promoting. So I will say main, enter. And you can see now we got a main branch. Okay, now once you got a main branch, what next? It's time to connect to the remote repository. Now this is a local repository. We need to create a remote repository. But the problem is, how will you connect your local repository to the remote repository? Now that's a big issue. So we have to set something called an SSH. Now how do I do that? Now basically there are two options. One is HTTPS. You can also get these steps here. And you can see something is changing here. If I click on SSH, things are changing. The advantage of using, so first of all, when we use HTTPS, basically to push, anyone can push, right? This is my remote repository. You can also push. How do I know that who should be allowed? Now that's where when we use HTTPS, it will ask you to log in. So if you are saying you are Naveen, how do you prove yourself? So you have to log in. Otherwise, you can use SSH. The problem with login is you have to log in every time. What if you can just set up your machine once with a key, and then every time you do something, it will automatically detect who you are. And that's why you have to set up the SSH. Now the way you can do that is by using very simple thing, which is SSH keygen-o. This is the command we have to use. SSH -keygen -o. Now this is the only time you have to do it. Okay, you have to do it only once. It's not like for everything you have to do it. For one machine, you have to do it only once. Okay, I just messed up there. So I will say SSH keygen-o, enter. And you can see now it says generating a public and private key. Basically, that's how you create a key to communicate between the client, your local copy and the server. So it says enter the file name in which the file will be stored. I don't want to mention anything here. It will go for a default name. I will say enter. Oh, the thing is in my machine I already have this created. I will just overwrite. I will say yes. You will not get this option if you have not done this setup before. Then it will ask you for a passphrase. I don't want to mention any passphrase. It's like a password. Enter. Don't want to mention anything, and done. I got my file created. Now where will I find this file? What I will do is I will just go back to my folder, and if I say ls, in fact ls-a, okay, first of all we got SSH created. This is not the SSH. Okay, let's see the SSH where it is. So if you can see, this is the folder which we are concerned about. This is where it went. So I will just go to that folder using cd /.ssh, enter. Let me just clear this screen. And now if I say ls-a, you can see we got our published here. Let me open that. So I will say cat id.pub, and we got the key, right? This is where you will find your key, in the pub. Now, where do I use this key? We got the key here, right? But how do I use it? It's very simple. You can just copy the entire key. Okay, copying is done. Where to paste it? It's very simple. If you can see here, let me click on here. I don't want to lose this page, so I will just open a new tab using the control or command button. I will click on settings, and you can see setting is open here. And then if you scroll down, there's an option of SSH. And if you see this, I already have some keys here. Ignore that. I will click on new SSH key. I will give a title to it, Git course 1, because I already have one before. And then you paste your key, that's it. And click on add SSH key. And now your client and your server is connected. So connected does not mean it is continuously connected. Every time you push something, it will verify, okay, it's coming from a right person, because I can see the SSH key, which is mentioned here, and on the local machine, they are same. Okay, so now once we have done that in the terminal, let's go back to our folder. So which folder we were working with? I think Git course, yeah. And if I say ls-a just to verify, and you can see we have the same thing. Now if I go back to my steps, so we are done with this step, right? Branching. Now we'll just use this particular one, and that too for SSH, okay? So I will just copy this and paste it here. Now what we are trying to say in this is we are doing git remote, because that's a remote repository of GitHub. We are adding a origin with this link. So this is where we are trying to connect. And when we say enter, connection done. Okay, so basically we are trying to map it. Once you have mapped it, now we have to move this file, which is in the local repository, because this is in local, right? The remote is empty at this point. So what I will do is to push the code, just copy this, paste. So what we are saying here, we are saying git push. Push means we are pushing the data from the local copy to the remote copy. And then we are also mentioning that there's a different branch and origin. So basically U is upstream, set up the upstream, and then the branch name is main. Okay, this is something you have to remember. Sometimes you will messed up with main and master if you're referring to some other documents. In the earlier documents, earlier versions, people used to mention master, and now we are mentioning main, so you might get confused there. And if I say enter, it is pushing the code. Okay, it will take some time, but before pushing it is verifying, hey, the key is there. Is it the right key? Yes, I think I only have one key here. Enter and done. The pushing is done. That's what it says. It says counting objects, done, total, done, setup to track. Okay, looks like everything is done. How do I verify? I can simply refresh my page and we got it. Now this is a file which we created in the local machine, right? And if I open this, you can see this is the data we got. Okay, now this looks cool, right? So basically we were able to push the repository from the local machine to the GitHub. And every time you work on a project now, these are the steps you have to follow. So basically we were able to push the code from our local repository to the remote repository, right? And then we followed some steps and it is done. Now that was your first commit, right? But what if you want to do some more? You want to build the entire project and you want to push. Of course, you will not do it from normal command prompt. You will be using some IDE to build your project. Now, this can be for normal book writing as well, or making a video script as well. But let's stick to VS Code here. So of course, you can use any IDE for that matter, or any editor. So if you're using a normal notepad, of course, you have to use a terminal or command prompt external to your editor. But since in VS Code, we have editor as well, and then we got terminal. So what I will do is, first of all, if I want to use VS Code, I have to open that folder. Now, which folder? Now, if you go back to your terminal, this is where we are, right? So if I clear, and if I say pwd, which is present working directory, I am into this folder, which is git source. So whatever files we have here is into this particular folder, which is git source. Now I will open that in VS Code. So I will click on file. I will say open folder. It's into Naveen, git course, open. So basically I have opened the same folder. Okay. So we got that file here, right? So if I open this, this has the same content which we had earlier. But what I will do is, instead of working on this file, let me add some more files, or at least one file. So I will say, let me say this is my user service. .txt. Now basically, let's say if you're building an application, the reason I'm doing txt is because it can be any programming language, right? Java, Python, C#, it's your choice. So let's say if you're saying user service, we are building an application where I want to do something with user service. Maybe I want to accept user data. I want to process some data on it. So let's say user service. And here I will say get the user data. So that's it, nothing fancy, just one line of code. In fact, this can be a normal programming code as well, but just to keep it simple for all the languages, we are using a normal text. So we are saying get the user data and save. Now, if you see this particular file is there in your working directory, it is not even there in Git. And also this file is not even there on the GitHub. This is what we want to push on GitHub. How will I do that? So let's go back to VS Code. And if you want to do any of this, we have to say new terminal. And we got a terminal here. And here, basically, we have to say git status. Now, when you say git status, you can see we have a Git repository inside this particular folder. But this file, which is user service.txt, it is untracked. We need to track it. So how will you do it? It's very simple. To track it, we can simply say git add, and you can mention the file, which is user service.txt, enter. And now we have added that into staging area. How will I know that? Let's say git status, and you can see now it's into staging area and we can commit it. How will I commit? Git No, at least I think at this point you remember all the commands, right? So git commit -m, and you can pass a message. So you can say user service created. Now it's always a good idea to type at the same time when you're watching this video so that you will know what is happening, right? So here, if I say git commit, and now we have committed it, and that's why you can see the U here went off now. Okay, committing done. But does that mean it is available on GitHub? No. We have done the commit on the local machine, right? Now we need to push it on the GitHub. And for that, we have to remember that command, git push. So let's use git push. And then you have to mention origin. So basically for pushing, we have to say push. And the origin is the URL. Remember the URL which we have used before? That is what is representing this origin. And then you have to mention the branch. The branch is main. We are pushing on main branch. I will say enter. It will take some time and done. You can see pushing is done. So from your local machine to the GitHub, let's verify. Go back to GitHub now. It's still not here. Refresh. And you got it. So you can see we got this file, which is userservice.txt. And if you open this, you can see we got the data, which it says get user data. It is available now, right? So let's get back to our project. These are the two files we have. And if you observe, we have two commits here. Now, what are the two commits? If I open this, two commits here, this is the first commit which we have done, where we created one file, which is readme.md. And this is your second commit, which is user service created. Now, you can actually, at any given point, you can go back to the earlier version where you don't have, let's say if you don't want user service, I can click on this particular file and it will give you the status of that commit. So in the first commit, we had only one file, right? That's what you can do. So it's fun to navigate between different commits if you want to go back to any commit and if you want to see what changes you have made. In fact, you can click on the file as well to see the changes. So if I go back here and if I go back to any file, okay, let's go to commit and click on any commit here. So it will mention what changes you have made. So we have created this file, which is readme.md, and this is the change you have made. In fact, you can go to the other commit as well, which is here, and you can see what changes you have made. Of course, it makes sense when you have multiple files and you can see all the files which are changed. Okay, so that's how basically you add your files to the remote repository. Let's talk about tags. Now, what is tag? We'll talk about that later. But before that, I just want to show you one more thing, which is about this remote. Now, if you remember in the earlier video, we have done this push, right? So from the local machine, we were able to send the data to this server, right? So basically we were able to push it. Now it has four things. First of all, we have a git command, of course, because we're using git tool. Next, we have push. Basically, we are pushing the code, right? Whatever data you have. And then we have something called an origin here. Okay, so we'll talk about origin because that's very important for this part. Then we are specifying the branch name. So it can be main, it can be master, or any other branch which you create. Let's talk about this origin. Why it has to be always origin? Of course, we have done origin, but it can be different as well. The thing is, for this particular repository, what we have done is when we talked about the remote server, we only have one. Example, if I say git remote -v. So this is the command using which you can see which is your origin. So we can have a origin for fetch. So from the server to client, this is the link we have to use. And from client to server, again, we have the same link because we only have one remote repo there. And by default, the name is origin. Of course, this can be any name. You can change it as well. So you can rename it, or you can connect to different repositories, not just one. And you can pull and push to any other repositories if you want. The only thing you have to do is you have to change this one. So instead of pushing it to origin, you can push it to somewhere else. Okay, so keeping that aside now, let's talk about tags. Now, basically, we have a concept of tagging. Now, if you have observed, every software which we use, it has a version number. Example, I'm using VS Code here. And if I go to help and if I click on not help here, because in Windows, you will get that in help. In Mac, you will get that in the about. So if you go to about VS Code here, so you can see it is giving you a version number here. So every time you download a software, you will get a particular version. Of course, you will also get the updates for it. So you can simply go here and I can check for the updates. So you can see it says restart to update, but I don't want to restart now, but you will also get update there. So this is the current version and this is a commit. Now this looks weird, right? Why do we have a commit in the about? That we'll see in some time. And also observe some things, because in the next video, we'll talk about this thing in detail. Okay, so we have Electron, we have Chromium, we have Node.js, and all these have versions, okay? So we'll talk about it in some time, but important is we have a version here. Now this version is basically a tag. So let's say if you're working on a project and then you have done several commits and now you think, okay, I'm all set to release my next version. So you can give a tag to it. And then once that version is done, you can go for the next version. So basically, how do you give this tag, the version number, to each commit? So not exactly each commit. Let's say you have done 10 commits and then now you think, okay, the software is up and running. We can publish this particular product to the users. We can give it a tag. First of all, how do I check how many tags I have for this project? Now, the way you can do that is by using something called git tag. And when you say enter, it will show you all the tags which you have given till now for this project. And this is empty is because we have not given any tag. So let's give our first tag here. How will I do that? It's very simple. You can say git tag. And then when you say tagging, there are two options here. One, you can use annotated tagging or you can use lightweight tagging. Now, if you really want to release this to the users and if you want to give more information about the user, I mean, who is committing it or who owns it. So if you want all those information, use annotated. Okay, otherwise you can go for lightweight, which we're not going to see. So let's see annotated here, where every version will have different information about it. So for that, we have to use a -a as an option for the annotated one. And then now you can mention your tag number. So basically, these are your version numbers. So there are different ways of using version number. Some people simply go with 1.0, like this version, or you can also mention V here. So V 1.0. So we can go with this particular one, which is V 1.0. This is our version, which you are specifying here. And then you can also provide a message. In fact, we need to do that. Otherwise, Git will open an editor where you have to mention this. Otherwise, let's say M to give the message. And I can say first release. So you can give something like this as a message. And when you say enter, now tagging is done. So you got the first tag. Now, if you want to check, you can say git tag again. And you can say we got one tag here. And of course, you can also see detailed information. So you can say git show v 1.0. Now, this will give you description about this particular tag. And when you say enter, this is what I was talking about. So for this particular tag here, this is the tagger who has given the tag. And then, so that's my name and my email ID, which is hidden. So the commits which I have done here is, this is the commit which we have done. And this is it. So I have done this. So, okay, first of all, let me just check all the thing done. Okay. So if you see here, we have done the tagging, right? But the tagging is available only in my machine, in the local copy. So every time you push, example, let's say if I do some changes here, I want to say this is get user data, and I will say process. So basically we have done some changes, right? Process the data. So we have made some change to the software. And now every time you make a change, you can say git status. You will get the status. What's the next step? Okay, so we have to add. So we have to say git add user service.text. What next? Again, we can say git status. It says now we can do the commit. Let's do the commit here. So I will say git commit -m, and you can give a message now. I can say processing user data. So we have added the new feature, right? So let's do that. And of course, in the real life project, it will be a bigger code. We're just trying to keep it simple. Enter, committing done. But the commit has happened only in local machine. We have not done on the remote. Because if you see, this is a local one, right? If you go back to your remote, and if I go back to Git course, you can see we have done the commit yesterday. So basically, I'm recording the video one in a day. So we have not done the commit here. So if I open this, we only have get user data. We don't have process user data. So we have to push, right? How will I push from my command line? I can say get push origin main, right? This is the command you have to use. And when you say enter, so it will try to push now, and that's done. So pushing on the server done. Let's go back and refresh. So you can see it says now, and this is a new commit which we have done. And if you see the data, we have added new line. Okay, so this is working, right? But then if you observe on the server, there's no tags here. You can see 0 tags. In fact, before the commit, we have created the tag. In fact, after the commit, we have done the changes, right? We should create a new tag here now, which is v1.1. This is a new tag, and we'll say a message We can also do a daily release, right? 27th June release. So normally, a lot of companies, they release their product in 6 months or 1 month. Let me do it every day. So I will say enter now. So we got a new tag. How will I know that we have different tags here? So we have seen the command, right? Which is git tag. Now you can see we have 2 tags. But if you go back to the server, it shows 0 tags here. So if I refresh, 0 tags. So what we need to do is we need to push the tags as well separately. We cannot simply push the code and it will have a tag. No, you will not get that. So what I will do is I will say git push origin and we have to mention the tag. So let's push the 1.0 and that's done. So you can see the new tag is created. And if I refresh, you can see we got 1 tag. And if I click on this tag, this is a version 1. And if I see in fact, you can download the source code and it happened 4 minutes before, right? Okay, so it will give me the source code itself. Okay, we don't need the source code. Okay, but you got the idea, right? So basically, we can jump between different codes based on the tags as well. And now let's also push the version 1.1. So we got 2 different tags. And if I refresh, you can see we got 2 tags here. And based on which tag you have, you can download it. So this is 5 minutes before, and this is 1 minute before. So different tag will have different codes. Okay, so you can see this is first release, and this is the 27th June release. Awesome, so this is working. This is how you basically work with the tags. So till this point, we were able to work with our own repository on GitHub and local as well. But what if you want to work with some other repository? Maybe you want to clone the code and you want to see what is happening there. Or maybe you want to push, or maybe you want to do some changes and use it for yourself or push it to this remote repository again. How will you do it? Now, first of all, let's find some project. Now, since we are using VS Code, which is open source, so what we can do is we can go to GitHub. So you can do a search here, which is VS Code. Now, if you search for VS Code, you can see you will find the source code. This is the source code, which has so many stars here. And this is from Microsoft, so let's use it. Now, this is the actual source code of VS Code. Now, the version which we are using is 1.79. Remember when we were doing the last video, if you go back, code, about, so this is the version, right? 1.79.0. So the current version they have is what? So, every project will have a README file. You can open README file, which is here. It will have some updates, right? Otherwise, you can just go here and you can look at the commit history as well. So this is the commit history. And you will also find tags here. Okay, so if you go back to code and if you see tags, so you can see this is the latest version that's verified, which is 2 weeks back. And this is a version which I'm using, 1.7.0. And if you want to see the commits of it, so there are so many commits for this particular tag, and you can also see you can also see the numbers. So how will I get the source code? So if I go back to VS Code, and we have seen that, right? So if you want the source code, of course, this will be a bulky project. So if I click here, you can see this is where local, this is where you can get the thing. You can also download the zip, but we don't want to do that. What I can do is I can use HTTPS or SSH. And of course, I will not be pushing any code. So HTTPS works for me. I will just copy this and go back to, in fact, I will not do that in VS Code. Let me use a normal terminal. So I will go back to terminal here and I will say, let's go back to the folder. Okay, let me see where I am. So I'm into my home folder. Let me just clear the screen. And this is where I will say git clone. I will mention that particular URL. The moment you say enter, it will download the entire VS Code repository in your machine. So it will take some time. So basically the entire project which we have here, we are getting that in this machine. So by the time it is downloading, let me see if I can find something interesting here. So the entire VS Code is built using TypeScript, 2% JavaScript. There is also Rust elements here and CSS, HTML and others. And you can see the number of contributors, more than 1800 contributors. That's great. And then there is also branches here, which we'll see later. But if you expand this, you can see there are so many branches here created. Important is the main branch, which is the most important branch here. Okay, done. So you can see I got the VS Code, and what I will do is I will open that VS Code in my VS Code. Okay, this is Inception, right? Opening a source code in the VS Code. So let me go to VS Code and open that folder. So I will say open folder, and in Naveen we got VS Code, open, and voila. This is the entire VS Code source code, right? This is the entire code. In fact, you can also verify with the README. This is the README which we had there, right? Okay. Now, what I want to see, I want to get some information about it. So what I will do is I will say terminal, and I want to know some things from this. So basically, I want to see the log first. So when I say git log and look at all the commits which happened here. So you will see their name, who has committed it, and what is the email ID. You can see the time when it is committed. And if you say enter, you will see all the list. Right? We got the entire list. And it will be huge. Now, if you want to come out of this, just type Q and you are out. Okay, and now, what if you want to see all the tags? I can say git tag because now we know the commands, right? And these are the tags. So they started with 0.10.1. And if you go down, the latest one is 1.79.2. Let's see. So if you go down, okay, still searching. So these are all the versions of VS Code. Okay, so you can see 1.9.1 is the last release, or they have the tags. I'm not sure if they have publicly released it, but they have the tags. And this is a version which I'm using. And maybe I want to know more about my version which I'm using. So what I can do is I can say git show 1.79.0. That's a version I'm using. So you can see this particular tag got a commit from this particular author and on this day. Oh, great. And I can also see what they have done by exploring this particular commit. Okay, you can see I got the commit number now. So this was I was looking for, right? So I don't know why I was not able to find that, but yeah, it's here. In fact, when you say git log, you can see there are a lot of logs here, right? Now, if you want to print only the commit number and just some information, there's one more way. You can say git log pretty equal to one line. So what will happen is by entering this command, which is git log pretty one line, you will see the commits and the message there. And this is how you message, right? So you will also get an example by looking at other people's commit, how they message something. So you can see we also have some number, issue number, and upgrade numbers. So it was always helpful to look at other people's comments or messages so that you will know how you should be writing your messages. Now, what if you want to make some changes? Let's say if I go back to any of the file, this is the first time I'm downloading the VS Code on this machine or exploring the VS Code source code. I can just get into source code and VS, let's say code. There is some node code here. Okay, so let's say in this particular file, if I want to make some changes, I'm not sure will it work if I make a change, but if I make some change, let's say, is there anything where I can type any message here, an existing message? Or let's say I just want to say on Windows, let's say I'll give a colon. Maybe I have done a very big upgrade to this particular project. Now, how will I push it? Of course, you have to commit in your local machine first. So what you will do is if you say git status, and you can see that I have changed one file. This is a file which we have changed, a cli.ts. And if you want to, you have to add it first. You have to say cli.ts. Okay, so first of all, you have to get the path, right? You have to go to that particular path and then you have to say commit. So if I say git status again, this is the path which you have to go for. So I will just copy this. I'll say git add, enter. So that's the path done. And now I can simply say commit. So git commit -m, and I will say major update, and I will say enter, and done. The commit is done, but that's only in my local machine, okay? And now if I want to push this to the server, let's try what happens. Even if something goes wrong, we'll see later how do we solve it. Now, first of all, I want to know the remote, right? Because how will I push? So remote is origin. So I will say git push origin main. I'm just trying to push in the main, enter, and it will ask you for the username password. The reason it is asking me to sign in is because we have used HTTPS, right? And if you don't want to mention username password, basically we have to use the SSH. Now, even if you are logged in, it will not allow. In fact, let me just try that once again. I don't know why I have cancelled it. Okay, so it's authenticating and done. So you can see I'm logged in, but it says permission to Microsoft VS Code get denied to this particular username. So I'm not allowed to do that, right? So I can basically fork this project, or maybe I can just create a branch. Even that is not allowed. Let's try if I can create a branch here. You can see you cannot create your own branch, right? So you're not allowed to do that. So you have to be a part of a contributor here. So once you're a contributor, then you can do that. Right? That's how you basically work with the projects. Okay, so we have done enough talk on this. We'll try to see how do you push in your own project. In fact, we have seen that in the upcoming videos, we'll also work on branches, which will be quite fun. So yeah, that's it from this video where we have seen how do you download a source code and do some experiment with it. We'll talk about the Git branch. Now this is a very awesome concept which is there in Git, and this is what makes Git one of the best version control system. Now what exactly branching are, how do we use it, how do you merge two branches, and what may go wrong when you merge two branches. We'll try to understand that in the next few videos. So let's try to understand what is branching first. And for that, we need to get back to our project. Now, this is what we were doing, right, on VS Code. We were able to get the source code from the GitHub, but then we don't want to work with this, of course, because even if we can do some changes, I will not be able to push on the remote repository. So let me go back to our repository. So I will say open recent Git course. Now this is a project which we are working, right? And if you observe, we only have two files here, nothing fancy, just two files. And we got readme.md, we got user service text, okay, makes sense. And then the first thing you have to do is you have to always check Git status if everything is committed. You don't have anything in the unstage or modified stage. So you can see we have Git status, everything is clean, so we can go forward. Now, if you go back to your GitHub and if you see we are into Git course now, so basically if you see there are different things on the screen. One thing interesting is we have one branch. Now, what exactly this branch means? See, the thing is, whatever you do, okay, whatever work you're doing and you're pushing from your client side to server side or your remote repository, you have a branch and this is going into the main branch. Now, this is the name of the branch, which is main. And by default, when you create a project, of course, you do get either master branch or main branch based on which version you're using and which tool you're using. So you have to check this. What is your branch name, first of all? So for me, it is main. And you might have some other branch, that's completely fine. And there is no rule in the world that you should have only this branch name or that branch name. You can go with any branch name, that's your choice. But commonly we use main nowadays. And you can see we have one branch. That also means we can create more branches, right? So whatever by default you're doing, that goes into the main branch, right? And if you remember, when we were pushing the code from the Git client or the terminal to the server, we were using main as a branch. So we used to say git push origin main, right? But what if everything is working? So let's say you have a project, everything is working, and now you want to do some experiment. Now, one of the things you can do is, of course, you can do experimenting. Let's say I'm happy with my code, which is working fine, and then I want to do some experimental code in this user service. Maybe I want to create an avatar for a user, and all these are experimental, okay? I'm not sure how will I do it. So I'm just trying to add this feature. And now let's say this is a very bulky code, and this is not the only file you're changing. Maybe you're changing multiple files, and you thought it will work, and now it's not working, okay? And then the release which you did to the users, the earlier version, it has some bugs, okay? And how will you solve that bugs now? Because the moment you make changes and when you push this to the server, or when you push this to the GitHub repository, how will you come back? Because you have updated your main. See, one thing you can do, you can go back with the commits. So you can, we can actually time travel between the commits. So you can go back to the previous commit. But again, why to do all those things? What you can do is, whatever experimental feature which you are working on, or maybe your colleagues are working on, so you can work on a different branch. Now, this will not affect your main branch, okay? Example, something like this. You can just click here, and you can have an option here of creating a new branch. You can simply type, let's say, feature 1. Now this is a new branch which I'm creating here, okay? So you can do it from here on the GitHub, or, which is the best way, we can do it from the command line, right? So let's go back here and let me create a branch. So what I will do is whatever changes I want to make, I will not do that in the main branch, I will do that on a separate branch. Now first of all, we have to create a branch. So how do you create a branch? It's very simple. You simply say git. There are two options basically for branching. One is checkout. Now this is the older one and most of them are familiar and used to checkout. The new feature or the new command which we got is switch. I think this came in 2.23 version. So both are okay. If you want to use checkout, if you want to switch, that's your choice. Now for me, I feel switch looks much better than checkout, because sometimes you get confused with all these words, right? When do we use pull? When do we use fetch? When do we use checkout? So switch actually makes sense when you want to switch between two different branches, right? So, but then let's go with the older one, which a lot of people are familiar with. So you can simply say checkout, and you can mention the branch name. So the branch name is feature 1. Now, this branch is actually not created, okay? So we don't have this branch yet. And if you type this command and if you say enter, you can say it will say the feature 1 did not match any files known to Git. So basically, we don't have a particular branch name feature 1. So we need to create one. So for the first time, you have to create a branch, right? Once the branch is created, you can switch using git checkout feature 1. So what I will do is I will just type this command once again, git checkout. Now, since we are doing this for the first time, if you want to create a branch, you have to say -b, or you can also say -f a branch, both works. And the moment you do that, it will create a new branch, okay? So now the branch name is feature 1. And it also says, switched to a new branch feature 1. So basically now you have two branches. You got a main branch and you got a feature 1 branch. How do you know how many branches you have? So what you can do is you can say git branch, and you can see now we have two branches. We have feature 1 branch and we have a main branch. Now the question is, which branch is active? And that's why you will see this star. Okay, so star means you are, this is basically a pointer, which means currently you are on feature 1 branch, and you can see it's also in green color. Now whatever changes you make will be happening in feature 1. Let me show you. Let's say I will do some changes here, okay? So I'm adding new feature because this is experimental branch, right? So I will say create an avatar for user. Okay, I will say save, and imagine this is a lengthy code. I'm just typing one line, but yeah, it can be a lengthy code. So once I do that, what I can do is, of course, I can say git status, and you can see in git status, it says on branch feature. Okay, it's not saved. Okay, my bad. I was expecting some unstage, and then it was saying something. Okay, now it is, you can see I failed to save it, and now I have saved it, so it says modified. Now once it is modified, you have to say add, and you have to mention the file name, and then you have to say git. You have to commit this, right? So you have to say git commit -m, and you can send the message. You can say experimenting with user avatar. Okay, so basically we are doing experiment with the user avatar. That's what I'm saying here. And I will say enter. Now this is committed, okay? Now question arises, in which branch it is committed? It is committed in the feature 1 branch, okay? Main branch has no idea what you're doing with feature 1 branch. So you can imagine this is your main. So this was your last commit, right? Before doing the branching, this was your last commit, and main knows about this commit. Now what we did is we have updated some feature in a feature branch. Main has no idea. So that's a new commit, and only feature knows it. Feature 1 branch knows it. Okay, so this looks cool, right? Now, if I say git log, so you can see it will give you all the commits. This is a recent one. You can see this is a recent one. It says experimenting with user avatar. Just try to remember this. Now what I will do is I will just go back to the main branch and look at the code as well. So this is my working area, right? Look at this code. So the user service has one more line here, right? But if I move to main branch, how do I switch? How do I switch between these two? So you can say git branch or the git switch. So either you can use checkout or you can use switch. I'm using switch now. You can also use checkout. That also works. I'm switching to main. The moment I do that, look at the changes. That line actually went. It's because main has no idea about that new line. But if I go back to feature once again, you got the new line. So this is a beauty between when you work with different branches, right? In fact, if you have more files in the feature 1, it will also show those more files. And when you go back to main, again, it will come back. So that's how basically you create a branch and you work on it. Of course, you can create multiple branches, there is no limit. But what is the use of creating a new branch, right? Of course, if you can do something, you can do it on main branch. And if you're doing something new on the feature 1 branch, how will you get that data in the main branch? Again, that's a question we still need to answer, but we'll do that in the upcoming video. Now in this video, let's try to create some more branches so that we can also see how do you delete a branch, and also what's a shortcut to switch between branches. So let's try this first one. Let me create some more branch here. So I will say git. How do I create more branches? I can simply say switch. Of course, you can use checkout or you can use switch, that's your choice. If you're using a checkout, you have to use -b option, and if you're using switch, you have to use something called -c. Now you can say -c or you can say --create, that's the option. And then you can mention the branch name. Let's say I'm creating a feature 2 branch. Okay, so I'm creating one more branch now. So in total, how many branches we have? We got 3 branches. How do I verify? So either you can say git branch. Now this will give you the list. So there is one option. Another option is --all. Again, both does the same thing. But the difference is in this git branch, you will see the local branches. In git branch all, you will see the local branches as well as the remote branch. And if you can observe, in the remote, we only have one branch at this point. If you go back to your GitHub, we only got one branch. Okay, we don't have this feature branch yet, so we only have one branch. But we'll see how do you push a branch to the GitHub. Now at this point, we can see we have only 3 branches. So we can check those things with the help of git branch, or if you want to see the remote as well, you can say git branch all. Now, let's say, again, if I say git branch, we are into feature 2, right? Now, what if you want to move back to the last branch? Now, since we say switch, it has created a new branch. But let's say if I want to go back to the previous branch, I can simply say git switch hyphen. The moment you do that, now you can see it is switching back to feature 1 because we came to feature 2 from feature 1. Okay, so if you want to do that shortcut of going back to the previous branch, you can say hyphen. That will be making it easy. Now, once we have seen this, let's also talk about deleting the branch. So you can say git branch, and you have to use -d. So if you want to delete a branch, you have to say -d, or you can say -delete, that's an option. And then mention the branch name, which is feature 2. Let's say I don't want to work on feature 2. So you can simply say feature 2 and then done. So you can see it has deleted the branch. And now, if you check the branches, you got only 2. We got feature 1 and we got main. So now let's try to push the branch which is there in the local repository to the GitHub remote repository. So you can see we have a feature 1 branch, but if you go to GitHub, you don't have it there. So even if I refresh, so you can see in total we got 1 branch. So let's create one. So what I will do is I will go back to my VS Code, and this is where, okay, even before pushing it, I just want to make few changes so that it will look good. So what I will do is, first of all, I have to check which branch I'm into. I'm into feature 1 branch. And in feature 1, let me create one more file, which is for the admin. So let's say this is admin service.txt. And what admin can do is add and remove users, change the rules. Okay, something like this, okay? So again, I assume I'm just writing one line of code, but behind the scene there are multiple lines of code so that it will look good, okay? So now what we're gonna do is, first of all, we are into feature branch, and in feature branch, if you say git status, there is one file which is untracked. So we need to basically add this file, which is the admin service. Now, once you have added it, it's time to commit. So I will say adding admin service. Okay, so basically we have added one more service now. And if I say git status, everything looks good. But if you see, now we are into main branch, right? So if I see the branch, so we are into feature 1 branch. And now if I switch to the main branch, just look. So the moment I say enter, see what will happen to the files. The moment I say enter, you can see there is one file which have been removed now because the main branch has no idea about this file, and that's why you can see there's also cross here. But in main, we only have 2 files. The moment I go back to the feature branch now, feature 1, and if I say enter, And now you can see we got 3 files. So this is how basically when you work, you can actually work on those files. Okay, cool. But then I also want to push this to the GitHub remote repository, right? How do we do that? It's very simple now. So you can say git push origin, because that's the origin we have. And now we have to mention not main, because in the earlier case, we used to say main, right? But this time we are pushing a different branch, which is feature 1. And when I say enter, now it is pushing this particular local repository to the GitHub repository, and it's done. You can see there's no problem. It says on my remote repository, which is github.com, Navin Reddy 20, gitcourse.get, it has a new branch called feature. Let's verify. Let's go back here, and you can see it still says 1 branch, but you can see there's a notification here. Feature 1 had recent push less than a minute ago. Okay, let me refresh to see 2 branches here, and you can see now we have 2 branches. This is the main branch, but if you switch to the feature 1 branch, you can see you have 3 files. Okay, so this is the beauty of using branches, right? So you can also see that on the server. Okay, that's how basically you push the branch on the GitHub repository. So how exactly things are working here? So what happens when you create a new branch? Is it really copying the entire project and doing it? So let's try to understand that in the next video, where we understand how branching basically works. So let's understand what happens when you create a branch. So let's say you have just done the git initialization on the working directory. Now at this point, what happens is you get a different area inside your working directory, which is called your git, right, .git folder. Now basically, whenever you do your commits, of course you have to do these commits in some branch, right? And by default, when you say git init, it creates a master branch. So let's say in our case, we are creating a main branch, right? So default for us is main branch, right? Now, every time you basically do the commit. So let's say when you do the first commit, what Git does is it creates something called a snapshot. So it will take a snapshot of your files, right? And then it will give it's a commit number. That's your checksum basically. We have seen the exact code values, right? So that's your checksum. And then there's one more thing called pointer. Now how the pointer looks like, let me show you. So if you say git log, and when you say enter, remember this, we have seen this thing before. There's something called head. So at this point, it is showing me a feature because we are into feature branch. What I will do is let me just switch to, I will say git switch main. And now if I do the same command again, you can see it says head is towards main. Let's say we don't have a feature branch at this point. We only have main branch. And then the head, so that's your main pointer. So it is pointing to the main branch, right? And main is basically pointing to your commit. Now there's a recent commit is this one, right? Now let's say next time you are doing one more commit in the same branch, of course. So what it will do is it will take a snapshot. Now in this snapshot, basically you will have those files which have been changed. Okay, so it will not simply copy every file. It will copy those files which have been changed. Now you have a previous commit, you have a recent commit with the new changes. And then it will also have the parent commit. Why? Because if the files which have not changed is there in the previous commit, right? So basically it will have a pointer as well. So we'll see that later, how the parent look like. So it create a parent. So it also has a parent, it has a checksum and multiple things. It also saves data in a tree format. But just to keep it simple, let's say we have checksum and the commit ID or the commit hash. So the main is pointing to the new commit, the head is pointing to the new commit. And now we are doing one more commit. So what will happen is with the new commit, you will have a main pointing to the new commit and head pointing to the new commit. Yes, at any given point, if you want to go back to the previous commit, what you simply do is your pointer will move from the latest branch to the previous commit, whichever you mentioned, or latest commit to previous commit. Is that simple, right? Now what happens is at this point, when you create a branch, what is happening? Now basically, you have a main commit, right? The main branch. The moment you create a new branch, both the main branch and the new branch, which is feature 1 in this case, is pointing to the same commit. Now let's say you decided to upgrade your features in the feature 1 branch. At this point, it will create a new commit and your feature 1 is pointing to the new commit, right? What about the main? Main is still with the old commit. Right? So that's how basically you create two different branches and you can work on them individually. If you want, you can also work on main. Maybe you want to do some more commits there. Because maybe after the main commit, you found some bugs. Of course, you are working on feature branch, but let's say you found some bugs in the main. Now, of course, you will not directly work on feature 1. What you will do is you will create a new commit from the main. So the main will be pointing to the new commit now, and the features commit is pointing to the other commit. So that's how basically it creates the branch. Now, if you want to visualize this, of course, you can do git log. It will give you all the logs, right? But there's one more command. You can say git, let me just clear the screen. So there's something called git log, and you can draw a graph here. Now, till this point, we have not done any merging. That's why it is only showing to the main one. So it says, what are the commits? What was the message which you have done? So the commit and the message, and the commit and the message, if you say enter, you will see more. Now, if you want more visual representation, what you can do is, you can install one extension which is called git graph in VS Code. And okay, it failed to fetch. Okay, so you can see there is something called git graph here. This is the logo if you want to download. And when you say install, so it will take some time to install. I think it's done. And if you want to use it, you have to go to this particular icon here, which is for the get or source control. And there is an option here. So if you can see, this is a button which you have to click. And now you can actually visualize everything. So if you click on this, these are the things which happened with this particular commit. And this is what I was talking about, the parent. For this particular commit, this is a parent, right? This was the previous commit. So if I want to show you in the console as well, we are into feature, right? We should focus on the main, not feature. Because in this we are into main. So I will just click here. So yeah, this is the commit, right? The recent commit, and that's what we have here. And for this commit, the parent is one commit before that. So you can see it says parent. Now, of course, for one particular commit, you can have multiple parents. We'll see that later. But at this point, you can see we have only one. And that's why it says there's a plural form, right, which is parents. And that's how basically you can see the things here. So yeah, explore this, and we'll try to understand this more. So you can see at this point, we have created a new branch, which is a feature branch. Now, everything else is happening on the new branch. So yeah, that's how branch basically works. And now we also want to understand how do you merge two branches. That we'll see in the next video. So basically, now we have two branches, right? So if you want to see them again, what we can do is I can just clear the screen, and I can say get branch, and you can see we have two branches, right? And now what we want is we want to basically merge these two branches. We want to merge main and feature 1. So of course, we have done the work on feature 1. It looks good. I just want to merge it to the main branch. How will I do it? So the first thing is, first of all, let's explore the files. I am into my main, right? And if I go back to git switch, just check what are the difference we have here. So if I say git switch to feature 1, and you can see there is extra file here, which is admin service. I just want to check if everything is good, it's clean. And I also want to verify if we have admin service on the GitHub. So if I go there, if I refresh, so yes, we also have admin service here. So that looks cool, right? So now what I will do is, I want to merge the data or the features in feature branch to the main branch. How will I do it? How do we merge? So to do that, what we need to do is we need to use a very simple command called merge. Basically, there are two ways of doing it. One is merge, which we are doing now. And the second one is rebase. We'll see later what rebase is, but at this point, let's focus on merge. So we are saying git merge, and then we just have to mention the branch name. But to do that, we have to make sure that we are in the main branch. So if you check which branch we are into feature branch. So we need to move. So we'll say switch to the main branch. And now we can do git merge. So we just have to say git merge and the branch name, which is feature 1. And when you say enter, okay, it worked. The merge is complete. There's no problem. Sometimes you do get problem. We call them as merge conflicts. We'll try to create merge conflicts later, and we'll also see how do we resolve it. But at this point, there's no issue, and you can see we got git merge and it's working. How do I verify this? If you go back to your main branch, of course, we are into main branch, and in main branch, you can see we have admin service. Okay, that looks cool. I just want to see if git status, and everything looks good because the commits which happened in feature 1 also came into the main. Okay, the way you can verify is by doing a log, and you can see we were basically done this thing in the feature, But now it came into main. And we can also verify that with the Git graph. And if you see here, that's why we have done the merging, right? So now it came into main branch from the feature branch. This is what it says. Okay, so merging is complete. Now, if you go back to your GitHub, and if you see here, in feature one we have 3 files, but if you look at your main branch, we only got 2 files because the update is not happened on the server. Okay, there is one thing which I missed. Normally, whenever you do this merging and pushing on the remote repository, of course you have to push, right? The first thing you do is you pull your remote repository. We have not done that because it was safe for me because I'm not doing any, we don't have any collaborators, I'm not working on main separately, but that's a good idea. Always try to pull first, okay? Because when you say pull, so from the remote repository, you will get the updated code on your machine before merging, okay? So how do you pull basically if you want to do that? It's very simple. Let me just clear the screen. So you have to say git pull the same way you do push. So you have to say git pull origin, and you have to mention the branch which you want to pull, which is main in this case, right? This is the step which you should have done before merging, okay? But anyway, we have done the merge, and now it's time for us to push it to the remote repository. So we'll say git push origin, and we have to push main. Let's do that. Things are looking good. There's no problem, and done. You can see the pushing is done. Let's go back here, and when you say refresh now, in the main, you can see we have three files. So this is updated, and we are good. Okay, so that's how basically you merge.